Math Cats, let's start looking at the how-to utilities for graphing in 2 dimensions. Come up here to Algebra with 2 unknowns. And there are 2 graphing utilities, and these can be used by the teacher when they're explaining concepts that have to do with graphing. And the one that's on the lower level is one that I did earlier, and then the Graphing 2D is, in my opinion, an improvement and can be used right through the whole high school curriculum. This second graphing utility is used in the explanation solving systems by graphing, and if you look at this YouTube video to go with graphing systems, you will see the use of this graphing utility. Just take a look at it. It was set up so that you could type in a coefficient, and I can't even remember whether I made it so you could put in halves or what. It was so long ago, 1996. You could change the color of your line, and then you could graph. And then I gave a table of the last graph that was visited, and I was fooling around with finding trace values along the line. The x of the mouse and the mouse location, and the x of the mouse and the y of the last equation. And then you could put in another equation. And I don't know, I'm just making these up. So, and you could change the color of that so that one would be one color for the sake of discussion. And see, I didn't pick a lattice point here, but you can see how that would work. And I need to experiment here to see if I allowed you to put in -3 divided by 2. I think when I enlarge the screen, I may have done that. Let's see if the slope of that is 1, 2, 3 divided by 2. Yeah, it looks like you could put in fractional value for the coefficient. Let me clear the graph, and let's see. +1 divided by 2. I think when I did the last, yes, see, it comes through at 1/2. When I originally did this, these had to be integers or decimals, but I think now I have revised it so you can put in fractions, because sometimes the kids did that. This is the older program written in 1996, except for the improvement that you could put in fractions. And it's a utility, especially if you wanted to make different colors of graphs and see them on the graph grid. But this one for 2D, I was thinking for further use, even when you got to Algebra 2 or pre-calculus, sometimes we needed to do linear programming. So I made this graphing utility, which has scroll bars that change by the 10th, and there are the ability to put in 3 lines in y equals mx plus b form, and 2 vertical lines, which I think would be sufficient to solve some linear programming problems. And this will also help when you're trying to see the relationship between inequalities and equalities. So let's just look at this utility. You could use this with the worksheet instead of the other one, as I indicated in the program graphing solving systems by graphing. But let's just put in, see if you click on the arrow here, the graph grid changes by 1/10. But if I go back to 0, and you click in the white space, this is going to jump 10 of these arrows, and it's going to go to 1x, 2x, 3x. So say you were wanting to see an equation like that, x plus 2, and you're doing y equals mx plus b. Now, what I did here was made it so that in the click event of the equal sign, the graph changed, because I think a lot of times kids did not get this when we did inequalities. So if you click on the equal sign, you see it says y is greater than, and I've made an attempt to shade this, and then greater than or equal to, and have this solid line here. These are things that are not as clear on the calculator. Y is less than or equal to, less than, and then back to the equation. So you could have a system of equations, and you could find out where they cross for the solution. And if you wanted to, you can actually click and put points in. See, I can click and put in points different places. And so this might be useful for whatever you're trying to talk about. Remove points, they're going to go, but the lines are going to stay. And you can see this dynamic changing of the graph grid. So it's going to change as we click in this space bar. It refreshes the graph. And the lattice points are over here in this like table, the equivalent of the table in the calculator. So this might be useful when you're trying to explain it. If you had linear programming, you usually have some constraints on the x, like say x had to be less than 2 or less than 2, and let's see if we can't. Oops, that's not too good. What if you said y had to be less than that? You can put in, let's see, I don't know, put greater than that. You could look for areas that are shaded. I think if you had it projected, you might be able to shade it over top of it with the smartboard marker or the Promethean marker or whatever. But this would give you a chance to set up some equations for linear programming if you'd liked. And you can go back to the equations and just have the equal, and then let's see, deal with it that way. Anyway, so you could get a region with 3 or 4 equations, and I gave you these vertical lines because they can't be put in y equals. So this is the utility from which I call linear patterns, and you can use it to dynamically teach the changing of an equation with the change of a coefficient or of the y-intercept, or horizontal or vertical lines. Let's start all over again and say we were teaching the line y equals 4. See, there's the line y equals 4, and you could see then x, I shouldn't, that's, the yellow is not very good. Let's see. See, here's x is equal to 5 and y is equal to 3, and be able to point out the difference between horizontal lines and vertical lines. And then I guess you could shade them, whatever. Anyway, thought I should explain to you how this works, and the table's going to update every time you do this. And you can click on point. It's just a utility, a graphing utility. Thanks. Bye.